talking to someone, so I didn't say hi to her.
Guys, I'm a celebrity. My name was on Seth's abstract.
Yeah.
Yes, I noticed this.
Yes.
Proud.
Proud to know that.
But then my picture still had my green hair.
Yeah.
So we gotta take a new group photo.
Our most recent group photo, none of the members except Olivia and I still work there.
Why isn't William there anymore? Just
Didn't want
cause.
to. There was a lot of collision.
Really?
Can't upset with him.
No, but like the personality is.
Whoa.
That doesn't shock me though.
What excuse of Fred? No, sure.
He has a pre-lab that he needs to write for inorganic
That he didn't do.
because he's,
That he did late. Fred, I hope you watch this recording.
Yeah, Brad.
yeah. Irresponsible.
Yeah, Fred.
I need to,
Yeah,
I need
right
to,
at
I
the
need to
camera.
stop recording. One of my colleagues got critical feedback during the student evaluation because the colleague tried, it was for freshman chemistry, tried to cheer up things and make it like a game. But the game was not very successful. It is my feedback to you, telling to the camera, Fred. So the game was like one takes this softball microphone. The question is asked, and then the instructor counts to 10. Students who gets the ball needs either to answer the question or pass it to the next one before it counted. If a question is answered positively, everyone applauds. If it is not answered, everyone tells shame on you. And students were so enthusiastic. It went only once, but the student who wasn't able to answer just dropped the class, maybe even left it.
Yeah.
That's
As they should.
embarrassing.
As they should. If you can't answer a question, get out.
So what were you doing? You know what I mean? Oh, not like socially, but in the class.
What have you been up to?
Well,
We really liked Dr. Han. He was really nice.
Would you write an evaluation for him if needed? I don't know if he needs it. I just
Yeah, absolutely, we would.
because he was hesitant to substitute lecturing and he on the path to academic career, so he will need to lecturing like every day. So
is he in the physics department here?
in chemistry,
Doctor?
he's so productive that I don't care if he ever show up in the office. He just writes.
If you're getting stuff done.
Right, 5 papers per year.
Wow, yeah, he's really getting stuff done.
So he deserves any freedom.
Yeah.
Aw.
Okay.
Yeah, we would.
I don't know how to say to myself back to the subject. So back to the subject, where did you stop?
We got to lecture 19.
I can count, but in the material. But thank you. Anyway, I appreciate it.
I found a really good periodic table app.
What is that?
We got through probability distribution and then we talked about and coded stuff about probability distribution in MATLAB. But I think that's as far as we got.
Okay, so I have a practical question about your.
I may or may not have a practical answer.
That's okay.
It might be.
In your expression for probability distribution. Oh, by the way, you brought the homework. Thank you. Did you go to fully analytical answer, or it is like beginning and the end pictures? When our second part of today's class joined the discussion, maybe we will get the answer.
Okay.
Elsa told that you completed predicting probability distribution. And my question is, how deep you did it? Did you get it in final answer? Like at any point T, you can write an equation and you can plot it yourself, or it is more or less general equation and computerized probability distribution? I just do not want to repeat things that have been already done, but we can collect and enjoy you.
This, oh, my name's not on mine.
I
No, he only wants mine.
I may start recognizing you by handwriting.
I could not get anything more than just that one. I completely forgot about it until this morning.
Do it now,
I know, I tried, and,
but keep doing, send it today.
okay, well, okay, I mean, I ran it like 5 times, and this is the only photo that showed up for mine. I had a lot of trouble trying to.
Have you been to the lab?
Yeah, I was on the lab on Wednesday. And I was having the same problem. Like when I ended up getting the video, but when I was running it through, I would only get this one. And then like the very last, like if I show you Ava's, this, I would see this one, it would cut to this one. And it would just like be choppy. So it would go boom, 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 boom. And then it would just stop. And I wouldn't be able to go back and get any of the other photos. And so then when I was running through it today, I was gonna try and run it like 4 times to try and get every photo on its own. But I couldn't, because it wasn't running through, it was just showing the figure.
Huh?
I didn't print them out for our review.
Okay, yeah. Can you help Sam advise him what was wrong with his?
I don't know.
Huh?
I think I said you should rerun the code. We all did it a couple of times.
But he complains that figures flipping one after another too quick and do not allow to make a screenshots.
Or it just straight up doesn't run through. It's very like.
Let's try it again.
Does it run all the way through on its own?
No. I mean, like I'll hit run and then it'll run and it'll just pop up with the first figure and that's it. But I have.
Did you hit enter?
Yeah, then
You have to keep hitting
to the
enter.
next one.
But don't like hit enter a bunch of times, like
So
slowly
then
hit
it'll go
enter.
too fast.
Yeah.
Alright, I'm gonna rerun the code then. That might have been what I was.
Okay, yeah, thank you for the help.
You're welcome.
IT help, Ava and Elsa's IT help. That's the extent of the help.
So,
This is what we got through with Dr. Han.
Yeah.
This is, it was just this like rewritten a couple different ways, but this is kind of what we ended up with.
and David presented the same thing.
Yeah, in lecture.
Okay, you didn't get too more further than this.
Yeah.
No.
Okay,
Because this was what the board looked like at the end of class.
very good. At least I have my piece of bread for the day. Otherwise, they would cover my day. So, he go.
I'm right there.
He needs to wake up. No, not Sam, but his computer.
Well, that
Well,
was them too.
I like the camels.
Oh, we'll do camel science. Zoology.
Camel science.
So, the goal for today's meeting is to get the same probability distributions, but in fully mathematical way, so that we have answer in like sines, cosines that one can plot at each point of time and analyze it. So basically what we are doing today is we are trying to survive on the inhabited island that doesn't have computers and MATLAB, but solve the same problem. So we need to arrive to the same answer without any computerization. And I will go slides, then switch back to blackboard, and then we will be done. So on the blackboard, I will practice our favorite task from high school, the trigonometric identities. So I would need to simplify. If they will be simple, I will do myself. If they will be hard, I will invite someone to help. Let's see how it goes. Okay. Focus on.
Endless. Okay.
Can't wait to learn camel science.
Oh, I was like, why is there nobody in the classroom? That looks so weird.
Whoa,
Yeah, I wanted to
I'm in
focus,
on you.
I wanted to focus on the blackboard.
Now try, now raise your hand.
Yeah. Help, I'm sinking. Okay, at this part of the board is seen, I can, right, yeah, okay. And let's share the screen and go to our camel science. So,
Wrong legs.
why, yeah, where is from that? Why do you, why do you have this, camel science illustration? I,
The humps.
exactly, I did want to, use the right terminology and, I wasn't sure that I have it, so. Humps sometimes are called. Is it standard?
The mane is like the hair,
Okay,
like the long.
so humps is okay,
Yes, humps is okay.
okay, then, it basically, main goal is achieved. Long eyelashes, it's important.
Long eyelashes.
Closable nostril.
So, continuing camel science.
I didn't even know that.
What's the difference between these three camels? Or what is new or what is different?
Humps. Yeah, the humps, like the middle camel's humps are about
The same.
that, yeah. Like the amplitude or whatever is about equal. Left camels, the left, the far left hump is taller than the right. And then in the right camel, the right hump is taller than the left.
All humps are acceptable.
Yeah.
So basically you are done with today's class.
Yeah, class is done.
My goal is to provide mathematical justification for these three figures. And can you make an analogy? Is it connected to what you were doing with David and Dr. Han?
I mean, it looks like the like animation we did.
Oh, yeah, because it starts like this,
Yeah.
and then it
You know
ends
what I mean?
and then
Exactly, yes.
it keeps moving.
Okay,
Does this make sense?
so I have a
The actual words for it, but.
I do have a hidden wish that I may not ever implement, is to convert this course into entertaining section for kindergarten. The quantum mechanics for 3 years old. And then these camels would be appropriate. Because we are in civilization of advanced technology, everyone needs it. Okay.
I love that.
So
Yeah,
you were correct, right?
yes.
So they either left is bigger than right, or they equal, or right is bigger than left.
Mhm.
And it is, I believe it is what you achieved in the class.
Yeah.
Great.
Okay, so this is done by computational assistance. And we need to get mathematical equations, which look a little blurry, but by the end of the class, they will be a little more sharper.
Okay.
So at different time steps, we have different relative heights of the humps. And the main idea is, if we go a little bit backwards, when you were presenting the postulate of quantum mechanics, you were telling, and maybe you remember that if the quantum system has stationary eigenstates of the Hamiltonian, one prepares system in the eigenstate, if you stay there forever without a change. Something like that, right? And superposition, summation of solutions is still a solution, right? But summation of solutions will not stay the same if you have some dynamics. And we are studying these dynamics, how superposition of quantum states bring in picture that changes over time. On one of the simplest examples. Okay, so you have done this red X, right? And Sam is about to complete it. Yeah. And here are the homeworks that Sam is going to email next Friday, and the rest of you will just bring it.
Yeah.
That one's due next Friday.
Yes.
Part 2 is due.
I'm very careful with formulations. I have very positive feeling to you and this year class, but formally it can be set up like next and coming Friday. So the closest Friday.
Okay,
This is due in 1 week from today.
Exactly. Yes.
yes.
Just to avoid ambiguities. So our today's class has no relation to this homework, but Monday and Wednesday in the lab, we will get enough training to complete this homework. Since you have already voted or just straw voted for projects, there could be a couple of homeworks on MATLAB rather than derivations, although we will do derivations later again. So this will be again a MATLAB, and this coming homework will be an absolute must problem to those of you who deal with either non-science or conjugated algorithms. You will see. And it is maybe it will be the last code before we go to the computational tool to do projects. So after we will be done with this homework, we will go into more advanced code that we will use to the end of the semester.
Is there any way you would be willing to type out the questions like in an email? So that we have it?
We did so much for the last 12 years. Maybe I can even offer extra credit to those who will type it and attach it to the homework, so that they can use it next year. It's my duty to type them, and I'm thinking, okay, maybe closer to the time I present, and then, okay, I woke up too late and I need to come to the class next year, and it rolls over. But you're absolutely right. I have nothing, no excuse.
Because it looks fine. I just want to make sure we don't misunderstand anything.
It looks fine for you because I barely can read it myself. So you got this picture, right? From David.
Yeah.
So, oh, you can tell me what density matrix is. I should focus camera on you, and then
No.
it's much more fun for me to interview rather than to mumble something myself.
We're telling you what the density matrix is?
Yes.
That would like probability.
Why matrix?
Yeah, that would make me a little nervous. With this iPad hanging off the edge there.
Oh,
Why a matrix?
Yes. So probability is typically continuous distribution. This like in continuous variable is changing, and probability is like this or this. And matrix is typically something discrete. And what is the connection between what we do with this probability? Why it is listed there as an implementation of density matrix?
Can you like confine it to some bounds?
Well, our particle in the box is already confined in the bounds.
Do you want me to just have the photos in my text or like
Minimalistic.
just?
Here are my beautiful figures, enjoy. Well, maybe a little more. Just label. Here is probability, here is stationary, here is snapshots, something like this. Do not invest too much time. So imagine picture of melody and go back to the subject. So what is discrete? How many states did we include into this dynamics? Two. So is it continuous number of states or discrete? Okay, and we have continuous eigenstates for state one, state two, and they come in squares, like first squared, second squared, and first times second, second times first, right? And then each of them are added together with some proportionality coefficients. So how many terms are in the expression for probability, for continuous probability distribution?
3, 4.
Generally four. Some of them can be merged. Okay, and 4 is a discrete number.
Yes.
And coefficients in front of each of this term are time dependent. And this coefficient, like space depending function, is found once forever, the eigenstates, but time dependent part changes, oscillates. And for different quantum states, oscillates with different frequencies, but there's a discrete number of these factors in front. And if, like, we have two states, total number of factors is 4, which can be just combined as a matrix 2 by 2. And it gives probability, and some people historically didn't believe in probability. They thought it is a density distribution. Like, where the peak is higher, there's a higher density of particles. And this is a matrix that helps to find density. Density matrix. Okay? So I'll try to ask you next time.
We'll try to remember.
I got it. I'm trying to.
So density matrix. Density matrix come. So we do excite from halfway from ground to excited, right? You saw it. Where is the density matrix in this picture? Where is the density matrix in this equation?
Bottom.
Yes, and upper box, right?
Yes.
So we have summation goes from 1 to 2, 1 to 2, 2 eigenstates, and then the time dependent factor. And this is object with 2 indices, like matrix. Did they communicate it? He didn't introduce density matrix to you?
Oh, you did.
Because I'll check the recordings and check him, because density matrix is the subject of his thesis.
So you better know what I'm talking about.
I was gonna say, yeah, I know he brought it up a couple of times.
Yeah.
Okay. And it is initial coefficient and then evolving in time according to difference in the energies of eigenstates. So here is the probability distribution that likely you did encoded and presented in your homeworks, right? So you have 4 space-dependent functions, and then you do have the time-dependent functions, which are element of density matrix. Maybe in the code they even named as rho 11, rho 22, or maybe P11, P22, something like this. Yes?
Yeah.
Okay. When you did it, one can combine similar terms and practice Euler, right? And replace this exponentials to cosine, and then you did simplification. That the I need to go back. But we still have time because it's not in the single thing. So let's go back to this definition. Would you agree that generally square matrix has diagonal and off-diagonal elements? Right? Okay. Diagonal elements means indices are the same. Right? And indices correspond to quantum states. Now, which of these terms correspond to diagonal, which are to diagonal, and how do they evolve in time? I have clear mind, but I have ambiguity of which illustration would be better. So if the indices are the same, what will be the difference? E sub I minus E sub I. Zero. So how would the diagonal part, when indices coincide, evolve over time? Trivially, it will not change in time, right? And if it is off diagonal, then it will get exponential complex phase. Now we get here. So top two are diagonal for first, diagonal for second, and then the next two are off diagonal. And we see that there one half, one half. Just probability that system resides in the quantum state number one, probability that it is resides in quantum state number two. And these two off diagonal, they are often referred to as transition densities. So they are non-zero if system is like in transit, if there is a superposition. So top two lines correspond to diagonal, and then next two transition are combined together. So about at this point, you moved onto easy life with assisted by computers. Right? So you just program this equation and plot it at different points of time. If I don't have a computer because I cannot pay for it, or if there is no electricity, I am on the island, the civilization didn't invent computers, I need to, but I still want to know particle in the box dynamics. I need to solve this mathematically, right? So I just need to be able to plot this expression for any value of t. And if I have this ambitious goals but excessive laziness, instead of all points of time, I select only most representative ones. So initial time, quarter period, and half period. Do you repeat, David? Or he didn't go too far to this point? Okay, so again, it would be a little more funny and enthusiastic if I do it on the blackboard, but then it will take more time. And I see in your eyes that you are on the border. If I show one more equation, you all will fall asleep. And I don't know what to do. If I go to the blackboard, we will wake up, but lose time. So if I want to explore this distribution at different times t, I can process it in an organized way as a table. So I can write down what are the values of the density matrix, of the elements of density matrix at each time. 1, 2, 3, 4, and there are 9. Let's go. Let's go and no, don't look here. No. No. Yeah. How do I use this? Oh, I know. I need to enable editing. Yes. Enable editing and then restart. Okay. Sam, would you like to be a front man? Just try a couple. But usually you'll be the next.
Supposed to take a guess, Sally?
Well, everything was kind of shown in the previous. And even if you are sure, just express your vision, what you're doing. I'm staying here and do not know what to do.
Well, I was gonna say, I don't, I was kind of still trying to figure out my,
but try.
I don't even know what the thing on the.
Or express how you
Okay.
interpret the task.
Well, if at time zero, your density matrix is gonna be. In one, like there isn't gonna be any like potential like distribution because time hasn't. Gone by, and so you don't have the
Good.
probability.
So, does probability that we find electron in the first quantum state,
It's not gonna change.
it's not going
at
to change,
time
but
zero.
if you prepared it halfway excited,
Yes,
what is the probability to be in the,
50-50,
okay, one half,
one half,
one half,
one half,
one half, and I think enough.
enough.
Well, you can put one half here, there and there and there, but then there will be no tasks for the rest of the class. But you're correct.
Yay.
The diagonal elements do not change. So you did 75% for others. Okay, thank you, Sam. He did most, but it was the simplest.
Oh, Sam.
Missed it. He did a full like hands behind his head.
If you don't answer just right, if you don't just express, how do you imagine what is just right over his smile?
I'm so good.
My God. Smile.
Well, I think it is Sam's smile, right?
Smile.
There's an answer that goes there.
I know,
And the
it's
answer
fine.
isn't smile.
If you use the back of the pen, it erases.
No way.
That's
yeah.
a lie. Are you
You're
serious?
so smart.
It does, right?
Okay,
That's fire.
it's filled up already.
Yes,
I would.
so you need to do only this one. So the summation of diagonal elements on the previous slide, what was it?
So rude.
Help to Patricia, what was the summation of row 1, 2 and row 2, 1 on the previous slide?
Row 1, 2, and row 2, 1. The cosine delta E.
Yes. Yes, cosine something times t.
Yeah, correct.
Cosine
Cosine something that
times
doesn't
t.
matter.
Before writing, cosine of something times t. If t equals 0, it will be cosine of 0. What's cosine? Cosine of 0. Perfect, thank you.
The answer is 1.
Those things.
Okay. Now, once I had a, like, it's not a close friend, but it was a, like acquaintance who sent me a text message, and I was just busy and lazy, not answering. And then he called, like, have you received my message? And he told something positive, and I needed to answer humoristically so that he doesn't feel upset. I'm not answering because I don't know how to react on your message. You're like, I do not know whether to put thumb up or a heart to it. So now I'm in the ambiguity. I don't know who will go to the blackboard first.
Oh, I just did it.
Thanks, Eva.
Excuse me, sir.
Never written on here before in the last.
Okay, well, if you.
Oh, you're rolling the sleeves. Okay, I'll put the very good number.
If you plug this expression for T in, then the H in the delta E cancel. So then it's just the pi over 2.
Yes, fine.
And cosine of pi over 2 is 0.
Sine of pi over 2 is 0. Yes, correct. Thank you. Excellent. And we all are thrilled and intrigued
Oh, are we now?
to learn from Elsa.
I have not only this,
Would
I have my.
Teach us.
Also your turn.
Like if you want the question sound complicated, like what will be the value of diagonal density matrix element at time pi h bar over delta E. And if you want question to be simple, it would sound like, what is the cosine of pi?
Well, because if you plug that in, it gets canceled out.
Exactly.
So then you end up with just the cosine of pi. What is the cosine of pi?
I shall be right back on that point.
-1.
Thank you, thank you. Okay. Glorious completion of a complicated and challenging task.
It's so good.
Let's check if Sam was correct about. Oh, yes. It works. We used his method to wipe off his smile.
Yeah.
So, and here are just snapshots of what students in previous years answered, and we can give them credit, they did good. Okay. So now, here are the probability distribution for half-excited particle in the box at 3 representative times. 0, half, quarter period and half period. Now, if you can identify, I did use your effort. So here is one half from Sam that I put here. One half in front of the sign.
Is your name on that?
Yes. Extra probability. Oh my God, I'm so smart.
So here we have both one half, and we can put them outside of the brackets, right? Here one half there. Then for any time step, the factor in front of this, here the sign of pi x, so it's just one half, one big half. Here is 2 pi x, but they both come in the same proportion, 50%. Like there, and there. And here we have 1, 0, and -1 from Eva and Elsa. You see it? So we used the values of density metrics to just open this summation and extract the probability distribution at different time steps. Now, since I assume that we don't have computers, I do need to simplify and plot these expressions by bare hands.
Oh gosh. Oh boy.
So how do we do it? If this is sine square, so it's square root of something. If square of a sine of pi x over L. Can we call sine pi x over L as A? Then it will be A squared. Then sine of double argument can be B. Then it will be B squared. Everywhere there. And here we have A times B times 2. Correct? With plus or minus. So probably one can simplify it. Yeah, better let's mute the screen and try waste time on drawing. Otherwise, it will be very. I don't to see my borders.
Yeah, you guys want to go get some free subs? Jimmy John's, not one free subs at the JC student.
At Jimmy John's? That's right to buy my apartment.
Say that's the.
So at time equals 0, one half, and we can already consolidate. Right, sine pi x,
I love her, but I
plus sine 2 pi.
Do you want to do?
X
Could you
over
on
L.
Zoom at Jimmy John's?
What now? Let's practice high school trigonometry. What is the sine of double arguments? Sine of 2x equals I need to discover to so that your glory will be. Yes, so sign of double argument.
Sign of double argument,
Sign of double argument.
sign of double argument,
Sign of double argument.
sign of double argument.
Double argument sign of.
C. Ja. Da. Wie.
Yeah.
Natürlich. Come on, this is the only.
Sign of, like, oh, that's two sine x cosine.
Huh? Two sign X.
Am I not just like the smartest?
Oh, yeah. I always
Well,
read those ones.
I want to give only positive feedback all the time, but sometimes situation needs to be a little be careful because of Julius Caesar.
Hey, if I end up like Caesar, I'm not gonna complain.
He told in his memoirs, it's better to be the first in Provence than second in Rome. So
Cheers to that.
no 1/2 sine by L plus 2
Peter.
sine
Interesting direction.
by XL cosine by XL. And it's all square. So, if I want to simplify it, and simplify means factorize. Some already helped us.
Yeah, come on.
What are we?
Actually, okay, can I,
Yeah, you can.
if you do, well,
Go,
okay.
go ahead. And now we need to refocus camera on the,
My goodness.
yeah, on your humble face.
Alright,
Do you have to repeat?
so what we can do is anything. Nope, never mind what I thought. One sec, just chill, just chill. Well, we can pull out. Sine of pi x over L. And we have 1 plus sine. Oh, wait, no, you're right. It would be cosine.
Yes.
And then,
Let's refocus on this little symbol 2.
that's squared.
And this. Okay. Yep, you did the hard part, and now I'll do the easy part.
I was gonna think that you'd be able to simplify the cosine plus the sine, but then I realized that.
It's already good. Now, our goal is to plot it. If I don't have computer and I still want to answer the question. So, how do I plot this function? First, I will do this one, and then multiplying by square sine is quite easy. So, first, I will draw cosine of pi x over L. So if you go from 0 to L, cosine starts with 1, right? Goes through 0 and with -1. So it is cosine pi x over L. Now we need to multiply it by 2. Okay. Now we need to add 1. What does it mean, add 1? We just shift it up, right? So we redo the x's in here. And then this becomes -1, 0, 1, 2, 3. Yes, you're following. Now we need to take square. Right? What does it mean how to take square? If you be all positive, right?
Yeah.
Where we had 0, it will be 0. So, then where it was 3, it will be, x is not to scale. 3 squared will be how much?
9?
I want to believe so, yeah. So 9. And then it goes to here. What will be square of -1?
1.
1.
Uno.
Uno.
Hold on.
And then it will go not sharply, but total smoother approaches of this. So the point where it intersects, here's a little observation. Original function was intersecting is 0 in the center of the box. Now this updated function touches 0 to the right from the center. You see it? Okay. Now we need to multiply. So we already done this part.
I have a question.
Yes.
I do not know how you got the 2 costs, how you were able to plot on the graph.
Huh?
The 2 costs, you were explaining it on the graph.
It's not me, it's Sam.
No, there's
So
no
ask us-
expression on the graph,
On the graph?
yes.
So you multiply by 2. So cosine changes from between -1 and 1.
Are you-
Cosine changes from -1 -2 to 2.
Are you curious how we went from the sine pi x over L plus sine of 2 pi x over L to the sine x plus 2 sine of x?
No, she's asking about graphical. Like she's asking why cosine goes this way and 2 cosine goes this way.
Oh,
Okay,
cool.
okay, I guess.
And instead of doing it twice, I just relabel the x. Okay. Now, how do we multiply things on sine squared? What is a sine squared at x equals 0? 0. What is sine squared at x equals L? What is sine of pi?
0.
Okay. I don't remember. So, and what will be sine square of something times 0?
Sine square of something equals 0?
Yeah.
0.
So our resulting function will touch 0 in 3 points. Here, there, and there. And then it will be a continuous function. Boom, boom.
Ooh, like a
It's a
camel.
And it's a hole.
Okay.
And it gets smaller and smaller.
Now, you got the main idea, and I will kind of over, but we will run over the rest of the slides. But
Not
they,
over me.
no, not over. So, if we perform the same
Because then you get your tuition paid.
little trigonometry, so upper line is what Sam derived, bottom one will be with minus, and in the middle, they will be, the sums will be equal. So if you carefully draw the things, and here is 2 cosine, that's what Risha asked about. Here we shifted it to 3, here we made a square, and then we multiply it by this green thing, green dashes, which are sine squared. And the resulting thing is this fat blue camel. Right? And
Yeah.
then if we do the same things with minuses. And if one does it with minus, it will be just shifted. It will touch the x-axis to the left from the center. So basically, we get 3 camels, right? And if you run them, the rest of the probability distributions will be in between this represented point. Okay? So even without computers, we could do this problem and predict the outcome. So meeting is done.
Meeting is done.
Have a nice weekend. Looking for no homework, just relax, accumulate.
I appreciate it. We have a test on Tuesday we gotta study.
Analytical.
Yeah.
Huh? Yeah, I think it's in Ag Hill.
Yeah, I went yesterday. Ice cream too.
I didn't know if I could go. I missed Seth's abstract and I'm kind of bummed about it because I didn't know if I was able to go or not.